I will explain more details about the white light and the ranges of the wavelength of this white light. So, first of all, light is made up of electromagnetic waves. And when I say wave, we are interested in the energy of that wave, or what I call frequency. And I am also interested in the size of this wave, which is the wavelength in nanometer. Now, the wavelength identifies the color of the light. So, let's look at the white light or the electromagnetic waves. Now, our eyes are only designed to see this only portion of the light, which we call the visible light. The radio wave are the smallest or the weakest waves in energy, and they have the largest wavelength. Our eyes cannot detect radio waves. We cannot see the waves of this kind. Not even the microwave or the infrared. Actually, we have specific devices that people can use and put on their eyes, which enable them to see the infrared waves, and usually detected at night. Like, for example, if we are in the forest and looking for animals or any kind of activity, we might use specific goggles to see and observe the infrared. Now, the microwaves are a bit stronger than the radio wave, and the infrared waves are even more stronger than the microwaves. As we see here, the more energetic the wave is, the smaller the wavelength of that wave, the smaller the lambda. Now, after the infrared, the range of these wavelengths, I'll tell you about the range in a minute, is designed, or this is the range that our eyes can see. And that's why we see orange, yellow, blue, red. We see all the colors of the rainbow. And all the colors that we see are derived from these colors. But after that, the waves, the electromagnetic waves, becomes stronger. And when I say stronger, I mean more energetic. And here comes an example, the UV light or the UV waves coming from the sun. We do not see them, we just feel them. Or, for example, like black or dark dots on our skin. More energetic or with higher frequency, we have the X-ray, which enables us to see the bones. And the X-ray tests that we do at hospital, when we look at someone, we can definitely not see the bones and the organs inside that human being. But with special machines, we can, called X-rays, we can see those. And eventually the gamma rays are so powerful, they are so much energetic. And when I say energetic, it means they have a very high frequency. However, their wavelength is very short. The wavelength is very short, so it becomes very small. So again, the electromagnetic waves, they have the longest wavelength. We use them, for example, for communication. They have the longest wave and they are the weakest in energy or frequency. Whereas the high frequency waves, like the X-ray or the gamma ray, they carry enough energy to ionize atoms and molecules. They can even damage living tissues. And these waves, they have a very short wavelength. So again, this is another representation of the electromagnetic spectrum. And the electromagnetic spectrum is a continuum of electromagnetic radiation containing all wavelengths and frequencies. Again, as we move from radio wave to gamma rays, the wavelength decrease, the wavelength size decreases lambda, and the frequencies measured in hertz increase. They become more energetic. Now, our eyes can only detect the wavelength in this range, what we call the visible light. And the visible light, you have these, the visible light is over here. This is the visible light. The red, the orange, yellow, green, blue, indigo, and violet. Now, to be more specific, any range of wavelength between 380, or you can even say 400 nanometer, and 750 nanometer, it falls in the visible light range. Now, of course, the violet are the larger wavelength, so they are more energetic than the red ones that falls on the 380 nanometer. So this memory tool helps you memorize the order of the type of waves on the electromagnetic spectrum, like the radio waves, the long radio wave, the radio waves, the microwave, the infrared, the visible light, the UV light, the X-ray, and the gamma rays. So you can memorize these words in order to know them in order. So let's take this question. Which kind of electromagnetic radiation contains the greatest amount of energy per atom? So in order to answer this question, we need to select the waves with highest amount of energy. Now I know that the radio waves are the smallest, coming next the microwave, and then the infrared, then the ultraviolet. So the greatest amount of energy is for the X-ray. And here's another question. Which of the following source of electromagnetic radiation will have the highest frequency? The highest frequency, it means the lowest wavelength. The lowest wavelength, it means I need to select the red wavelength. Here, we can either answer A or C. So I'm gonna take A, having a shorter wavelength than choice C.